All right, so example one. Actually, look at your formulas. This should be somewhat familiar because in theory you saw this in Math 2, Math 1, I don't remember. And then you should have seen it in Math 3. Okay. So these are all the different formulas. Go ahead and put a star next to this one. This one's new. Continuous exponential growth. So this one, instead of having R for rate, it has K for rate. If you notice in this, I went ahead and I made all the formulas kind of look the same. So there's a P in each of the formulas. That's a starting amount. Sometimes books don't say P. Sometimes they say A sub 0. A sub 0 just means amount. Sub 0 means like starting amount. The reason I changed all of these to P's is so that you guys could see that they're all the same. Does that make sense? They all start with a P in the front. But we know that if we look at various textbooks use different letters and stuff like that. Different teachers use different letters. All of these we can see a T. What does T stand for? Time. All these have the R. What does the R stand for? Rate. And we make sure that when we write the rate that we do it as a decimal. Where did I put that? Rate is written as a decimal. Maybe put a star next to that. Like if we had 6%, what would we write instead? Not 0.6, 0.06. 0.06. You guys all said 0.6 and then I wrote 0.6. Yeah, 0.6 would be 60%. All right, what if we had like 1.5%? 0.015. What if we had 0.5%? 0.005. You take the decimal and you move it 2 places to the left. Or you divide it by 100. Yeah. Okay. Down here, when we have the continuous exponential growth model, it's very similar to a continuously compounded problem. Instead of PERT, it's Pickett. Thank you. Thought of that myself. K is the growth rate, again, written as a decimal. Which means that these two formulas are basically the same. Compounded continuously is just usually the wording that's used in problems that have to do with money. Typically talking about accounts, interest rates, things like that. Exponential growth could be used in literally any situation where they say that it's growing exponentially and they use the word continuously. Or you know that it's like continuously happening, that's when we know that we can use that formula. Okay, and then half-life should be reminding you a little bit of chemistry. All right, let's go ahead and look at the first problem. So it says Carrington invests $300 of her tutoring money into an account with a 6% interest rate, making no other deposits or withdrawals. What will Carrington's account balance be after 20 years if the interest is compounded semi-annually? So if you look at the formulas, which of the formulas allows us to plug in an interest rate, allows us to think about 20 years, allows us to think about a starting amount of 300, allows us to think about getting interest semi-annually? Yes?
Compound interest.
Yeah.
This is so great. You didn't notice, but Eleanor had like nicely raised her hand.
Oh,
and I said yes to her. And then after she opened her mouth and you said compound interest. Perfect. All right, so the formula that we are using for this is y equals p times 1 plus r over n to the nt. The p value is the initial amount or the principal amount. That's $300. The R value is the rate of the interest, which is 6%, so we're going to plug in 0.06. The N is the number of times per year. Semi-annually means twice. Semi-annual sale would be like a sale that happens twice a year, so semi-annually is twice. The N here and the N there are the same N, which means if we plug in 2 for the first one, we're plugging in 2 for the second one as well. And then the T value is 20 years. So we're just going to go ahead and plug all this stuff straight in and figure out what's the final amount. We're going to do the same thing again for a monthly interest rate, and that would be taking your N and using 12 instead of 2. Okay? So I'm just going to go ahead and write down that stuff with those numbers plugged in. I've got $300, 1 plus 6% semi-annually, and then I have my semi-annually for 20 years. I also have my same equation, but for monthly. And for both of these, we're just going to go ahead and plug that straight into the calculator. These are the nice, easy problems. If we have this on a test, these are the nice, easy points. You just have to make sure you understand how to use the, like, which formula to use and that you can plug them in. Awkward. All right, so the first one is, and this is, what unit of measurement is this? It's money. How many decimals should we have if we do money?
2.
2 for the cents. So I'm going to write $, $978.61. And then to do the other version, I'm going to hit second to enter because it plugs all that back in for me. And then I'm going to go to the 2, and I'm going to hit second insert, and I can put a 1 in front. I'm teaching you how to be lazy. You're welcome. And then I go to the other 2, so it's blinking on top of the 2, and I hit second insert, and I can put a 1 in front of it, and I just changed my 2 to a 12.
What if we just
magic.
put 1, 2?
Then, hold on, I'll show you in a second. Let me get my answer. Let's say I wanted that 12 to be 112. 112. Oh no, it started to delete my other things. Mm-hmm. So you have to insert things if you want a new thing in here. Yeah. All right. We good on that part? Okay. So if I was to write this as a sentence, because I typically want you to answer story problems as a sentence, I would say if the interest is compounded semi-annually, then after 20 years, Carrington would have $978.61 in her account. If it was compounded monthly, she would have $993.06 in her account. Do I want to write it down now? No. Let's move on. When will Carrington have $5,000? Divide this space in half because we have 2 situations we have to check. One situation is where it is compounded semi-annually. One situation is where it was compounded monthly. So we have to check both of those because they're going to be 2 different answers. Okay? So up here, I'm going to write semi-annually. That looks weird. No, it's spelled right. Okay. And then monthly. All right. So what changes about the problem now that I know I want to end up with $5,000 and I don't know how long? Yes?
Instead of the Y, you can plug in $5,000.
Okay. And then what else?
Your time.
Yeah.
Value.
Yes?
Do you have a sheet? Look, I did this work on the wrong space.
That's fine.
But
If you can get another one, but you have to walk up here yourself. Okay. All right, and then what should we do for the monthly version? Yeah, so same thing. Oh. So now the variable shows up in the exponent, and how do we get to an exponent that is a variable? We take logs, which is why we're doing it in this unit. Doesn't that make a whole lot of sense? It's our log unit, so we're going to use logs. It's valid. All right. I need to move stuff away from the t. What can I move away from the t first? The 300. Okay. So I'm going to say divided by 300, divided by 300. I would love to say that 5,000 over 300 is a nice number, but it's not. So I'm going to go ahead and say, like, you could divide by 10. That takes away a 0. divide by 10 takes away another 0. I'm going to go ahead and call that 50 over 3. I can simplify that fraction, but I can't write the decimal because it's not nice. If you would like to write the decimal and then store that decimal in your calculator, you are welcome to do that. It's up to you. Okay. 50 over 3. And then in the parentheses, let's go ahead and figure out what this number is. 1 plus 0.06 divided by 2.
Wait, 2.06 over 2, so 1.2. No? So I was just converting
Oh,
the
you were
1 to 2
getting,
over
yeah,
2.
I got you. 2.06 divided by 2 would be 1.03. 1.03.
Oh, 1.3.
Yeah. All right. She was doing it in her head by getting a common denominator. Yeah. All right. So now we have an exponential equation, right? You guys see that? And I technically don't need those parentheses, so I'm going to erase them so they don't confuse us.
Hold up. What did you just do to get 103?
All we did is we added 1 plus 0.06 divided by 2.
It's kind of, I kind of got it. I don't know what.
All right. So we have something in exponential equation. We need to get the exponent alone, which means that we need to either Tootsie Roll to put it in log form, or we can take the log of each side.
Log of each side.
Log of each side. What's the base of our log? No. 1.03. Okay. So remember, this does not have to be one of the complicated problems where we log base 10 both sides and do like a whole long process. This is one where we can just switch it into log form and be good. Okay, so for me to switch it into log form, I'm going to say log base 1.03, log base 1.03, and a log base 1.03 and a base of 1.03. They cancel each other out.
Wait, Ms. Bryce.
Yeah.
So is your log base always going to be where the t is at, or the variable is at?
The base of the exponent becomes the base of the log.
Okay.
And this was the base of the exponent. If you did not like that version, you can Tootsie Roll the problem, you'd get the same thing. So you would say the base of the exponent became the base of the log. So log base 1.03 of 50 thirds equals 2t. You get the same thing by Tootsie Rolling. Okay, what do we do next to solve for t? Divide by 2. You are going to be doing this a lot today because this is the way the problem is asked in example 1. That is something you could have done if they'd shown you these formulas in 7th grade. This part right here, you had to wait until you learned how to deal with logs to do them, and that's this unit right now. Okay, so we're going to have a lot of problems where this is going to be the process. You're going to be asked to solve for time. Time is always an exponent. You're going to have to do a log every single time you solve for an exponent. Okay, if it's not a log, it's an ln. Okay, which is still technically a log. All right, so let's go ahead and type that in our calculators. I've got the fraction. I'm going to hit math, up, 1.03 of 50 thirds divided by 2. Margaret, I'm going to do it your way. Divided by log 1.03 divided by 2. Ta-da! Did you get it? Marvelous. Okay, so how many years? 47. 47.590. So for this, I'm going to go ahead and round to 3 decimal places just because that's our usual default. And this is not like example 1 where the answer was money and 2 decimals made more sense. This is something where, like, yeah, you could have a portion of a year, that's okay. Okay, so we are going to go through the next example problem, and we're going to do it exactly the same process. Okay, so what should I do first? Divide by 300. Divide by 10. Divide by 10. So we have 50 over 3 equals, can we simplify the inside of the parentheses? So 1 plus 0.06 divided by 12 is 1.005 to the 2t. we have a problem that is written as an exponential function right now. We want to undo the fact that it's exponential so we can get that t value isolated. 12t, sorry. I was focused on wanting to turn off the air because it was driving me crazy, coming off and on every 30 seconds. Okay, you were exactly right. That should have been 12. Okay, so how do we undo the fact that this is an exponential equation? We log both sides. Okay, hold on. This is for you. I know, Karen, you almost missed him.
You shouldn't have.
Yeah. All right, so we now have log base 1.005 of 50 thirds equals, and what happens with the log base 1.005 and the base of 1.005? Cancel, equals 12t. I just turned it off. I swear I just turned it off. Okay, what happens? I will turn it back on when we're done. It's just like, keeps coming on and off. It's annoying. All right. What do I do now? Divide by 12. Okay. And then I have to plug this in. All right. So if Carrington wants to have $5,000, then with compounded semi-annually, it will take her 47.590 years. Monthly, it will take 47.007 years, so just a little bit less.
Yeah,
but I mean, that's taking $300 of your own money, and eventually that $300 becoming $5,000, and you did not contribute anything to it.
I mean, that's still 47 years, though. Come on,
I know, but that's a lot of money that's not yours.
I'd rather spend my $300.
So Carrington, get $300, find a place where you can get 6% interest, put it in there, just wait until you're ready to retire. Okay. All right, example 3. Colby decided to invest $300 into an account as well, and he searched high and low and found an account which compounded interest continuously. All right? We are going to add to this, I forgot to say that it's at the same interest rate, okay? So we're going to add in here also at 6% interest. Okay. And they want to know when he will have $5,000 because we're going to compare and see which account made more sense for us to do to get money faster. Okay? So what formula should we use if we are compounding interest continuously?
Continuously exponential.
Compound interest, which is y equals PERT. PERT. All right. So tell me what numbers I plug in where. Okay, so but for y, what do we have? Wait, for y? 5,000, that's our final amount. Equals 300. What do we plug in for e? That's a joke, it's a button on your calculator. Okay. What do we plug in for r? 0.06. What do we plug in for t?
T.
That's what we're solving for, so we put a t. Good. Okay. What do we do first? Divide by 300. Divide by 10, divide by 10. So we have 50 over 3 again equals e to the 0.06t. Yeah. So this one, again, we're in exponential form. We want to make it in log form so we can get the exponent alone. And this time the log that we're going to use is an ln specifically because the base is e. So we're going to ln each side. Ln that side, ln this side. What happens with the ln and the e?
Cancel out.
Cancel, cancel. We have ln of 50 thirds equals 0.06 t. Divide it by 0.06. Okay. I'm going to let you guys do it because I seem to have misplaced my calculator. Oh, you guys just, you're like, Miss Rice will be my calculator today. Miss Rice, what'd you get?
46.890.
Wait, I'm not even done
All right. So, a little bit faster. Yeah, because Carrington had to wait 47 years. Colby only has to wait almost 47 years.
That's my boy right
Yeah.
there.
For the 5,000, you just think about like, you just think about it as like, euros.
Yeah. All right, go ahead and take your paper and flip it over. What? Who's that? All right, Kalia creates a town celebrating her joy in mathematics in the year 2025. The town has 110 people, and it grows continuously by 1.42%. All right, so let's look at our formulas. Which formula shall we use?
Compound continuous.
Not compound continuously. Continuous exponential. They're basically the same, right? It's just instead of an R, you have a K. It's the same. Okay, so we're going to go ahead and write that we have y equals 110. Oh yeah, we can go ahead and write the formula. Y equals PE to the KT. Heck it. All right. 110 people, grows continuously. All right. E to the 0.0142, right? Because we write it as a decimal. That means we have to take this and divide it by 100. And so we're moving the decimal 2 places to the left, and that's why it's 0.0142. T. Oh wait, not T. 10 years. And 20, doing it twice. All right. Are you guys plugging it in? All right. What did we get? Yeah, it should be 126. Can you maybe check a typo? There you go. All right. 126.783. Can we have 0.783 of a person?
No.
So I'm going to say approximately 127 people. We have a pregnant woman who's about ready to pop. That's what we're talking about here. Kalia, I don't understand why your math town is not more popular than it is, but it's growing rather slowly. All right. And then we're going to plug that back in and figure out 20 years.
I got that one. 146.
So 146 people will go ahead and run down. just because we're just rounding to the nearest whole number. Okay. So it's very confusing why this town would not be more popular. It has math and CLIA, but apparently people's love of math is not as strong as ours. CLIA, I would live in your town, obviously. I would be the mayor of Math Town. Okay. Okay. All right. Example 5. Candace and Terrell create a rival town across the river called Smoochy Smoochville in 2026. The town starts off with only 92 people. Surprised they have as many as that in Smoochy Smoochville. But has a growth rate of 1.53%, so it's a little bit bigger, a growth rate. How long will it take for their town to be the same size as Kalia's after 10 years? So what we need to do is we need to go back to Kalia's town at 10 years, and we need to store that number. So I'm going back to what I plugged in here. I'm getting that decimal back on my screen, and I'm going to store it. And what letter should we store it as? K. Marvelous. Okay. So let's go ahead and write down the information we have. Our final amount of people, we're going to check to see how long it takes till the population is 126.783. I'm going to go ahead and put a K there so I remember that's what I did. So that's our Y equals. And then what's our P value? 92. E to the... And then T, since we're trying to solve for time. Okay. So what do I do first? Divide by 92. So are we okay with me just calling this K over 92?
Yeah.
Okay. So my stored number for K over 92 equals E to the point 0153 T. I ln each side. So I have ln of K over 92 equals 0153 T. All right, so let's see how Smoochy Smoochville grows compared to Clea's Math Town. Kalia, do you see what this means? It took them 20 years to get as big as your town in 10 years, so you win.
Math is cool.
Math is better than Smoochy Smoochville. All right. We're going to add an example 6 because there's one type of problem I really should have put on here. All right. Corday starts a town.
It should be the sugary V8 drinks you drink.
Skittles. Something to do with Skittles.
Called
You won't name it.
That's
called Skittle-dee-doo.
I love that.
love it.
Which
Is that the Wonka factor or something?
doubles its population in 5 years. What was its growth
Oh my god, I don't got no more.
Right. I'm sorry. All right, Corday starts a town called Skittle-dee-Doo, which doubles its population in 5 years. What? My computer fell asleep. It's fine. Okay. What was its growth rate? Okay. Now, did you notice all it said was they doubled? They didn't say what you started with and what you ended with. That means you can choose a starting value and an end value. So if you want your starting value to be 1, then when you double, you get 2. If you want your starting value to be 100, then when you double, you get 200. Okay? So what starting value do we want? 1. All right. So we're going to say Corday's town starts with just him. And after 5 years, it's him and his wife. Yeah.
I mean, you know.
This has turned into a Mountain Man story. All right. So start off with 1, end up with 2. E to the K. K is actually what we're solving for this time. And that's because they're asking what's the growth rate. The growth rate is the K value. Okay? So K times 5 for 5 years. All right. What do I do next? Divide by 1. Divide by 1. So 2 divided by 1 is 2. 2 equals E to the... Can I write 5K instead of K5? You guys want it to look weird? That's right. So I prefer K5. All right. Now what do I do? ln. Okay. So ln of 2 equals 5K. Divide by 5. So ln 2 divided by 5 is... double check to make sure you ended your parentheses around your 2 before you divided by 5. Okay. 0.138, the 8 is followed by a 6, so it rounds up to 9. So what percentage was his town growing? 13.9% growth rate. I mean, that's pretty good. I mean, you only start off with 1 person, you end up with 2 people, but that's beside the point. That's beside the point. All right. How are we feeling about these problems?
Yeah.
Are we relatively okay?
Yeah, it's just hard trying to figure out what equation to use.
Yes. So how did we know, when we were looking at the different equations, how did we know? Look at the key words. So if it says compound or interest or compounded continuously, anytime you're using one of the formulas that says the word continuously, it's going to be a formula that says the word continuously, right? So continuously is a good word to look for. One thing that helps me is when we have the compound interest formula, that is the only formula that has an n value. So if they say something was compounded semi-annually or monthly or weekly or daily, or you could use it 1 for yearly or quarterly, something like that, that's when I know to use that formula. Does that make sense? Okay, so really the one you have to watch out for is this one, because this one, to me, the wording is a little bit more subtle. And the difference between this exponential growth and this exponential growth is only that word continuous. Does that make sense? So if it just says it's growing and it doesn't say continuously, then you're going to be using the first one. If it talks about continuous growth or it says something about finding the growth rate, that's what they call the K value, is the growth rate. All right? Does that make sense? Okay. So we're going to go ahead and get started on these problems.